Hi students, hope you have started your preparation and hope this video actually helps you for your preparation students. So what you're seeing is the notes for the first unit that I made you to write in the class, and this is the note that I have prepared, and the same thing I have uploaded in the Google Classroom students. The same notes I'm explaining you guys now. Okay, let's be simple and crisp. I'll not be taking much time. So yeah, see. So first, uh, the cryptography and network security students, as I mentioned in the class, like this subject, cryptography and network security, is the first step of this cybersecurity analyst job. So all the basics are covered in this subject. So getting into the subject, the first thing is the computer security. It is just a generic name for the collection of tools designed to protect data and thwart hackers is computer security. Okay, so obviously, you guys have to protect the data from the hackers that is mentioned in the uh, heading here. Now, network security. So the data will be flown over a network. Students, obviously, you'll be sending the data from the sender to the receiver, from source to destination, right? So you guys have to protect the data during their transmission. That is network security. Internet security is in the distributed system environment. So data processing equipment with a collection of interconnected networks. So if this is the situation, students, obviously you guys have to protect the data from the hackers. So final conclusion that we have made is virus may be introduced into a system physically and loaded into an optical disk, and it may also arrive over a internet. So virus may be introduced over a computer, students, and slowly get onto a network and slowly get onto a internet security. So that's what we have concluded here. Okay, and these are the security violations. So the first one is, here is a user and user A, and here is a user B, and user A is sending some information to user B, and user C, he got an unauthorized access and he's actually watching the sensitive information that is transmitted from user A to user B. So this is a violation. Next, a network manager D is actually sending some message to computer E. What he's saying is he just wants to add new users, okay, and who are given access to that computer, right? And what user F is doing is he intercepts the message, students, and forwards to the computer E as a manager. So suppose network manager D include the number of new users, right? He is sending two users, right? So in the computer E, two users will have the access, and user F, since he has seen the same message, he'll be sending two users again. So total four users will be given the access. So two users are unauthorized, and other two users which user F is sending, right? They are unauthorized. Two users are authorized and two users are unauthorized. Okay, next. Personal manager sending a message to the server to invalidate a employee account, but that particular message is getting delayed, right? So why we want to invalidate is some, for some reasons, for somehow, like he's not in the company, or he has done something, right? Employee, right? So by the time your that message is getting delayed, he must be doing some, some information security violation, right? So these are the three violations, students. Next, the actual subject actually starts with this definition: computer security, the protection afforded to an automated information system in order to attain the applicable objectives of preserving the integrity, availability, confidentiality of information system resources. So these are the three things that you guys have to understand: confidentiality, availability, and integrity. So whenever you are saying the computer security, right, you got to see that these are there in any network security or whatever the security you are providing. The first one is the confidentiality. So there are two things here. data confidentiality, and privacy. So what is data confidentiality? It assures that the private or confidential information is not made available to everybody, right? And privacy is something like it assures that individual control or influence what information related to them may be collected or stored, and by whom and to whom that information may be disclosed, right? So here what this one says is like you got to know whatever the private information is there, that should be made private, and it's not made public. That is not available to everyone. Privacy is whenever you are showing the information to someone, students, you should know like to whom you're actually showing. Is he an authorized person? He is your trusted person, like that, right? And next, integrity. Data integrity and system integrity. What is data integrity? Assures that the information and programs are changed only in a specified and authorized manner. So some change is going on a data, right? That should be done in a proper way. It's not just like that. You just change the data, right? Changing the data means there is a person who has the credentials. That person only will access the data, and that person will only make the changes. And system integrity assures that a system performs its intended function in an unimpaired manner, free from deliberate or unauthorized manipulation of system. Right. So if you are making some changes or a system, students, it should be free from deliberate or unauthorized access of the system. Right. Next, availability assures that the system works properly and service is not denied. If you are waiting for some response from the server, that response should come in time. If that response is coming after some time, then it's the service is denied for quite some time, right? And this is the triad figure that I was stressing on in the class: confidentiality, integrity, availability. So this is a triangle, students. If you need to assure on confidentiality, integrity, and availability, you should not compromise on any two or any one. If you are providing these three, then the system that you are actually saying is secure. This is called CIA triad. And the additional concepts is authenticity and availability, the property of being genuine and being able to be verified, that is authenticity. Accountability is the security goal that generates the requirement for actions of an entity to be traced uniquely to that entity. So if you are doing some changes, right? You guys have to you need to get back, okay, who had made the changes, and you can just you should be able to revoke the changes that you are actually doing, right? If you are not able to get back to the original state, right? If you are not able to get back to the original state, then that change is made by somebody else who has not having the access. That change is done in an unauthorized manner, right? Next is the challenges of computer security. So as mentioning, like, security is not simple as it might appear. So many of us think like providing security is very simple. It's not that simple, students. There are too many factors that you guys have to consider. And in developing an algorithm, one must always consider potential attacks. First of all, you need to understand like what is an attack on the security. Based on that, you have to develop the algorithm. And it is necessary to decide where to use them. So providing security, like, so this particular thing, right? I mentioned like your ID card. Your ID card displays your photograph, name, your roll number, sometimes your blood group, right? So, but the ID card does not display your account details, bank account details, right? So there are few things which can be made public. There are few things which should be made private. Computer and network security is an essential battle between the perpetrator who tries to find the holes and a designer or administrator who tries to close them. So always like the hacker tries to find a ways to actually get into the application, get access to the application's data. And uh, as administrator or as a designer of the application, you have to see that hacker is not getting access to that application, right? And security requires regular and even constant monitoring. The example that I gave you is the JNTUH students. It's a tool where it actually works daily, continuously, 24 by 7, right? It's a tool that's being installed at the server level, in the application level. So whenever you open the JNTUH, right, it actually shows the logs where there are errors, and if there is any security breach, that is also getting printed, right? And many users view security as an user-friendly operation, right? You should not, you should take this security at most with at most priority students. It's not just like that you provide the security, right? So these are the challenges, and down the line, so constant monitoring is one thing, and the fourth point, it is always a fight between the perpetrator and the administrator. These are the 2 points that we are stressing upon. Okay, and next, security attacks. A useful means of classifying security attacks used both in X.800 and RFC 2828 is in terms of passive attacks and active attacks. These are the two standards, students, which we are going to discuss in this security attacks. One is the passive attack, that is, there's a Bob and there's an Alice. Bob is sending some information to Alice. What Darth is doing is he's actually seeing the message that is sent from Bob to Alice. He's actually seeing. So this is release of message contents. And next, Bob and Alice. So Darth is actually observing the pattern of messages that are being sent from Bob to Alice. So passive attacks are very difficult to detect because this guys, this Darth is actually just seeing them. That's, he's just watching them. He's not doing any changes. Okay. Next, active attack. Bob and Alice students. So Darth will send a message to Alice. It appears that the message is actually coming from Bob. I've just written message is coming from Darth. The message is coming from Bob. So that's a masquerade. The next one is Bob and Alice. Bob sends a message to Alice, but Darth, what he's doing is he captures the message from Bob and he just replaces the same message to Alice, right? It's like send a message 2000 and you are sending the same message 2000 to Alice from Darth, right? That's a replay. And next, Bob and Alice. So what Darth is doing is he is just taking the message sent from Bob to Alice and he is just modifying the message and sending the modified message to Alice. So that's modification of messages. And next one is Bob and there's a server. So what Darth is doing is he is actually disrupting the service provided by the server, right? That is denial of service. So it's like you are requesting some information, but server is not responding. So this is about the passive attack and the active attacks. So remember these masquerade, replay, modification of messages, and denial of service, because we'll be discussing about these things again, okay, further in this. Right. Next, security service. This is one important topic, students, where X.800 is one standard that divides services into 5 categories. What are those 5 categories? Authentication, access control, data confidentiality, data integrity, and non-reputation. These are the 5 things, students. So first thing is peer entity authentication. So peer entity is, there are so many actors who are in the communication, students, and what you have to do is you have to give them confidence in identities of entities connected. So whoever is connected, you got to make sure that all are authenticated. Data origin authentication provides assurance that the source of received data is as claimed. So if you are sending some information to a destination, whatever the source is sending, right, the same thing the destination is also receiving, right? The receiver is received. He is not receiving some other information, right? Next, access control, prevention of unauthorized use of a resource. Okay, so if you are providing access to any of the resource, right, so that should not be unauthorized. Data confidentiality, so connection confidentiality, protection of all the user data. Connection less confidentiality is protection of all user data in single data block. Why I'm saying like single data block? If there is a connection oriented, there is a connectionless students. Okay, connection oriented is you just established a connection between the sender and the receiver, and all the data gets transmitted. Okay, once all the data gets transmitted, whatever the connection you established, right, that will be discarded. In connectionless, you don't have to establish a connection. Whatever the connection is there, on that you are going to use it. So once you are sending it, right, you'll be sending as a data block. So that's why protection of all user data in a single data block. Next, selective field confidentiality. So you don't have to provide the confidentiality on all the fields. So our name is known to everyone. Our ID is known to everyone, but not our account details. Right? There are few things like you got to maintain some privacy. Traffic flow confidentiality. Protection of info might be derived from observation of traffic flow. So you should not, there's a passive attack where the guy actually he observes the traffic pattern, the data that is being sent from the sender to the receiver, right? By observing the pattern itself, he'll be able to understand what kind of data is getting transmitted and what is the data as well. Next, data integrity, assurance that the data received are exactly as sent by the authorized entity. So he's making sure that the data is not getting changed over here. So there are several types here. Connection integrity with recovery. So provides integrity of all user data on a connection and detects modification, replay, etc. Right? So make sure that over a connection, right? So with recovery is if something happens, right? So he should be able to recover the original data, right? And connection integrity without recovery. So he'll be able to provide just the detection itself, not the recovery. So while actually speaking the terms with some security firm, right? You want with recovery or without recovery. Okay. That is like, suppose say you are just launching your application students. Just if the application is working fine, it's just like a demo session. So in that you can go for, without recovery because the data that is there in the application is a dummy data. So you should not be worried if the data is getting changed, right? If the data is lost also, you should not be worried. That's a dummy data. But if the application is getting deployed and all the users are using it originally, right, then you should go for connection integrity with recovery. A selective field connection integrity. So check if the selected fields have been modified. So here, so you don't have to provide the security or provide the privacy on all the data fields, right? So you can go for the selected fields. On the selected fields, once the receiver receives students, you got to check if the data got modified. Next, connectionless integrity provides integrity on a single connectionless data block and may detect data modification. Replay detection may be provided. Okay, so all these actually speaks about the connection, and this is connectionless. And selective field connectionless integrity provide for integrity of selective fields within a single connectionless data block. So once it is a connectionless, you speak about the data block because you are not going to send the entire information, but you are going to send the information in data blocks in connectionless. Next, non-repudiation is provides protection against denial. So it actually specifies on denial of service. So non-reputation origin prove that the message was sent by a specific party. So he is just concentrating on the sender. Next, non-reputation destination is prove that message was received by a specific party. To whom you are sending, only that guy is receiving. It is not received by any other guy who has the another who doesn't have the proper credentials, right? So these are the five category students, and if you just count 1 2 3 4 5 6 7 8 9 10 11 12 13 14, there are 14 services that should be provided by anyone who actually expose themselves or publish themselves as a security firm, right? And you guys have to speak on these terms. Okay. And next is security mechanisms. So the security mechanism is a method or a technology that provides and systems from unauthorized access attacks, and security mechanisms provides confidentiality, integrity, availability. So this is the triad that we are actually mentioning, okay, previously, that triangle diagram, right? Confidentiality, integrity, and availability, right? So what are the security mechanisms? So here, students, this example that you are seeing, right, I've just taken from the Oracle website, this one, right? So first of all, there will be a firewall to our system, right, to protect the system from the unauthorized access. Okay. And next, uh, it can be a local system or it can be a remote system. That is, the hacker is physically accessing our system, or he is accessing from a remote location, some other location. Okay. In both ways, that system access, hacker should not get, students, right? So if he get the access also, right, and he should not be able to logging in, right? And if he is able to log in, he should not copy or he should not download the unauthorized files like virus, right, into our system. Okay, I told like in the first, like virus actually get into a local system, then it gets into a network, and then it gets into a distributed network, right? So first have a firewall, next have the authentication, next have the authorization. This is what Oracle specifies. And what are the mechanisms? First is encipherment, hiding and covering the data, right? You need to use some security algorithms, which you are going to study in the unit 2. Access control, you need to stop the unintended access, right? So have the authentication, students. Notarization, involving trusted third party. Okay, you as a developer, you develop the application, but need not worry about the security aspects. Okay, maximum just involve the third party, students. You just go to a security firm, right? Those guys, will have the notary, like you can actually count on them with respect to security. And data integrity. So you need to see that the sender is sending the data and the receiver is receiving the data. Whatever the sender is sending, the receiver should be receiving the same data, right? Authorization exchange deals with the identity to be known, right? If you are sending, or if you are receiving, the receiver is receiving some data, right? Receiver should know, like, this guy has actually sent. It's just like a postcard or a letter you are sending, students. It's just like an email, right? So once you receive an email, so seeing that the sender's email, you need to recognize that this guy have sent. If the email is quite different, then you need to conclude that this mail has come from some spam, some scammer, right? Bit stuffing. So add extra bits and check at the receiver end. So you need to make sure that whoever is accessing our network, the secure channel, you should not be able to understand what is the original message, because we have added extra bits. This you are going to see in the security algorithms that we'll be discussing in unit 2, right? Next, digital signature is not visible to our eyes and sender identity to be notified. Digital signature is basically to actually check the sender's identity, students, right? I told you, like digital signature in the unit 2, right? You'll be using a hash algorithm. If on the receiver end, the original data hash and the digital signature, once you get the hash, the both hash are same, then you start doing the actual communication. If both the hash are different students, then don't do the communication. You just wait for the other hash. And this is the model security, a model for network security. So here you have a sender, this is a recipient, and here there's a secret info and security related transform. So you are going to use the encryption algorithm. So this is a secure message that will be transferred over a network, right? And here will be the opponent, and this guy will be, he'll be watching. This guy will be watching the information, but the opponent should not understand. That's a challenge, students. That is how you guys have to transform the message, right? Once the secure message reaches the destination, students, you need to give the same security information to transform that secure message into its original form so that recipient will understand, right? There is a trusted third party who actually, manages the sender, the recipient, and also the channel, right? So here notarization involve the trusted third party, right? So in addition to the application that you are developing, right, you guys have to provide the security. Just don't worry upon the security aspect, students. Just trust upon a third party, right? Some security firm. Okay, so this is the information about the first unit, students, and because I gave you the notes, I've explained this, and I'll be explaining the security attacks again with the different subheadings in the next video, students. Hope you like it. Uh, just start preparing for your first unit. Best of luck, students. Thank you.